Hi, this lesson is about pyramids and cones, and it's talking about the surface area and volume of these 3D shapes. Let's go ahead and get started. This is the information you would find in your flip book, and we're going to fill it in together. Today, let's start by talking about pyramids and the surface area. Remember, surface area is when we are covering something up. Maybe we want to paint it or wrap it with paper, or we're building the structure. So we're talking about the outside parts that create this shape. Okay? So this particular pyramid has a square base. So we're going to fill that in. I need my pen to work. So we're going to fill in our notes. So we have a square base. And the other faces of this shape, so let's go down here and identify the square. If you notice right here, this is our base, and we know it's a square. It kind of looks like a parallelogram, but it's a square because we can identify by the sides they're both 7. So that makes it a square. Then, if we looked at the sides that are going up, these are triangles. So these side faces are all triangles, and they come to a common point at the very top, and that's called the vertex. All right. Well, if we want to find the surface area, we would need to cover it up. We would need to find all of the outside areas. So we would need to find the area. We have one base down here. So our base is a square shape. And then we also have our faces, our sides, and our faces are all triangles, right? But how many do we have? Well, we have 4 of them. So whatever we would do, we would multiply our triangle form by 4 to get it. And then if it's a total surface area, we're going to add them together. So let's go back up to our notes. So the total surface area is the sum, because we have to put everything together, of all of the triangular faces and the base. That's just what we identified down below. We would want to cover up all of our parts. All right, so in this case, we want to see this blue line right here and how it's dotted down? And then it has a funky looking L. It's a cursive L. And that, if you notice, that triangle is kind of slanted. It's kind of leaning in towards the middle. Well, that L is the height of just that face. So we call that the slant height because it's the outside height, but leaning in towards the center. And we're also going to use the perimeter of our base. And the reason why we're using the perimeter of the base is because all of our triangles, the base of our triangles, are the perimeter of whatever the base is. So in the formula, we would see the letter P, and that would stand for the perimeter. Perimeter. Okay, excuse the sloppy handwriting. And we would also need to find out what the area of our base is because we want to cover that as well. So if you looked at a formula sheet that is provided to you, you would see that the formula they give you is 1/2 the slanted height times the perimeter plus whatever the area of the base is. Or, in a different way, that would kind of make sense, is it's your slanted height times your perimeter, and then we're going to divide that by 2 because we're talking about triangles, and then we're going to add our base. Well, let's go ahead and do this using the pyramid that we're given. So if we wanted to figure out what the base is, our base is 7 squared because it's side times side, and that is 49. Well, there's 2 different ways that we could find the other part down here for the faces. So if we used our formula, LP divided by 2, our L is 10, our slanted height is 10. Our perimeter is the perimeter of the base, and that is 7 times 4, so that's 28, and then we're going to divide it by 2. And when you do that, you're going to get that it's equal to 140. Now, A different way you might think of it is, well, what if I wanted to figure out what the area of the one face is, the triangular face? Well, that's base times height divided by 2. And the base is 7. The height is 10. And then divide it by 2. And that would equal 35. But we have 4 of those triangles that go around. So those 4 triangles is what the total side surface area would be. So 35 times 4, and that gives us 140. So there I showed you 2 different ways to get the same value. So we need our base, and we need to know the side triangular faces. So we need these 2 values, and we're going to add them together. So our total surface area is 49 plus our 140, and we would get that it's 189. They didn't tell us what our units are, so we're just going to go ahead and say units, whatever they might be, and they're squared because it's area. Make sure you have all this information. Let's look at our next one. Next, we're going to look at what the volume of our pyramid would be. So we're looking at the same pyramid, and volume is different because we're going on the inside. So the volume is the total amount of space or area that is inside the figure. Now in this case, this particular pyramid, or the pyramids we're going to be talking about, they are similar to a cube. Now why do you think they would be similar to a cube? Well, it's because the base of this particular pyramid is a square. And remember, if it's a cube, all of our faces are cubes. So it's similar to a cube, but if you notice, our faces are now triangular, and they lean in towards the center until they get to the very top, and they're doing that from all different directions. So we're really saying that the height is decreasing. So the value of our area of that space is really what's decreasing in all directions until it reaches the very top, and we talked about that as being the vertex. All right, well, when we are finding out how to actually calculate the volume, what we're going to do is we're going to multiply. You're going to multiply the base, whatever the base is. That's whatever the area of the base is, and you're going to multiply the height. And in this case, since we're on the inside, we want to use our inside height. So that would be this value right here. And it's always perpendicular to the base. So it's a straight line showing the vertex, connecting the vertex to the bottom base. So the base and the height. But since it decreases, we're going to then divide it by a value, and in this case we're going to divide it by 3. So on a formula sheet, what you would find is that our formula would say, oh, 1/3 base times my height. All right, so in easier terms, what does that really mean? It's our base value times our height, and then we're going to divide by 3. Well, let's go ahead and do that. Let's find the area of our base. So the area of our base is, since it's a square, it's 7 squared. So that's 49. And our height value is our inside height, which is 8. So we're going to multiply 49 times 8, and we're going to divide the whole thing by 3. So when you calculate that, you get a little bit of an uncomfortable number, and usually when we get these numbers that seem a little uncomfortable, we go back and check ourselves. But what you'll get is that the volume of this pyramid ends up being 130 and 2/3, or 66 repeating. We don't know the units, we're going to say units squared. All right? Make sure you have this information. Well, let's try another one. Let's try this pyramid. We want to do both the surface area and the volume. All right, so let's do surface area. Remember, surface area is going to be our length, our slant height times our perimeter divided by 2 plus whatever the base is. So here we go. The slant height is 5. The perimeter, our base is 6, so the perimeter is going to be 6 times 4, which is 24. And then we will divide that by 2. And then the area of our base, which is our shape down here, which is a square shape, so that's 6 squared, and that would be 36. So then we would get, if we continued, we'd get 120 divided by 2 plus 36, which then turns into be 60 plus 36. So our total surface area is 96 units squared. Very good. Let's do volume. Remember, volume is our base times our height divided by 3. So we said our base before was 36. Since volume is our inside, we're using our inside height, which is 4, and we are dividing by 3. Several different ways that you can do this. When you simplify and come up with your final number, you're going to end up with having a value of 48 units, and since that's inside, it's units cubed. Good, make sure you have this information. All right, let's go now and talk about our cone. These shapes are very similar in that they both come to a top point and they have one base at the bottom. Now the cone, this cone that we're talking about is called a right, there we go. It's a right circular cone in that the height right here is perpendicular, let's see if I can spell this out correctly, perpendicular to its base. The area of the base is pi r squared because, well, our base is a circle. There you go. All right, so let's go ahead and do this next part. So the cone has, it has a slant height as well. So if we're doing the surface area, again, we're doing the outside part. And it also has a slant height, just like our pyramid did. The height represents the distance from a point on the edge of the base, so this point down here, up to the vertex, okay? So again, this is our outside height because it's our outside area. So since surface area is the outside, we're looking for outside height, okay? So our formula for doing this is the total area covering the one base that we have and the curved side. So we're going to add the area of the base and the area of the base to the area of the side. So our area of the base is going to be, the surface area of our base is going to be pi r squared because it's a circle, and to the area of our side, and the area of the side goes around a circle, so that is pi r and then our slant height, which is L. Okay, so remember, units on surface area are squared. All right, so our formula is going to be pi r squared plus pi r L. All right, let's go ahead now and work this out. Okay, so pi r squared, so we have pi, and we have our radius, which is 3, so it's 3 squared plus pi times our radius, which is 3, times our slant height, which is 7. Okay, so we're going to have 9 pi plus 21 pi. Sometimes forms will be left where they leave pi. For most of our reasons and calculations, we're going to go ahead and multiply it using pi, or the value of 3.14. Okay, so 9 times pi is going to give us 28.26. Ooh, sorry, looked away for a second. And 21 times pi is going to give us 65.94. Now, I don't want you to worry about rounding at this point. Wait till you get to the very end. If we add them together, we're going to get a total surface area for this cone of being 94.2 meters, and it's surface area, so it's squared. Alrighty, moving on. Now let's talk about the volume. Again, volume is the amount of space that's inside, and in this case, what's inside this cone. It's similar to a cylinder. So this one is similar to a cylinder in that it has a circular base. So remember, on a cylinder, it has a circular base on top and bottom. So you have two bases, and then the space in between is our height. Okay? In this case, though, the space inside the cone decreases, just like our pyramid did. It decreases in all of the directions as it goes from the base to the vertex. And therefore, the formula is going to shrink by 3. Or when you see it on your formula, it's going to say 1/3, which means divide by 3, right? So our formula for our cone for volume is going to be 1/3 pi r squared. So it's pi r squared because of our base times the height, but it's 1/3 of everything. Okay, so what this means is that you're going to multiply the base. So you're going to do r squared times your pi, and then you're going to multiply the height. So you're going to multiply the height, and then you will divide by 3. And again, because we're talking about volume, units are cubic, which means like that. Okay? Well, let's go ahead then and figure this out. So volume is equal to pi r squared h divided by 3. So let's fill in our data. So here we go. So pi, our r is 3. So it's 3 squared. And our height is 8, and we're going to divide it by 3. So we have pi times 9 times 8 divided by 3. And after you do all of your calculations and get all of your work done, you're going to end up with a value of 75.36, and this is inches cubed. So that would be the total volume of this cone. Make sure you have all this information. All right, let's do one more. Let's do surface area and volume for practice. So for surface area, again, remember surface area is going to be pi r squared plus pi r l. Okay, so we have our radius, which is 3 squared, times our pi, okay, plus we're going to have the radius, which is, well, we can start with pi again, our radius, which is 3, and our slant height. Now, the slant height for this one, we have to calculate that, don't we? Because it wasn't given to us. They just said, and they used S. So, this is going to make, if you notice, a right triangle. Well, a right triangle means that we're going to use our Pythagorean theorem. Remember, it's a squared plus b squared equals c squared. So if you plugged your values in, you would have 4 squared plus 3 squared, and it's going to be equal to whatever our slant height is. Well, you'd find that this is 25, and it's equal to that, but this is a squared number, and we need to figure out what one slant height is. So really our slant height is 5. All right? So our slant height is now going to be 5. So we have 9 pi plus 15 pi, and if I do all of my calculations, 9 pi and 15 pi, this is 2826, plus 15 pi is 47.1, and when we add them together, we're going to get a total of 75.36. Surface area is units squared, so it's centimeters squared. Very good. Let's do our volume. Our volume is our base times our height divided by 3. And our base for this cone is pi r squared. Okay, this is what base is equal to. So we're going to do pi times 3 squared. Pi times 3 squared. And then we're going to multiply that times our height, not equal to. Multiply that times our height, which is 4. Okay, so pi times 9 times 4. And we're going to divide the whole thing by 3 because it's decreasing in area as it gets higher and higher. So 36 pi divided by 3. Again, you can calculate it lots of different ways. In the end, your final volume answer is 37.68 centimeters cubed because it's volume. Very good. Well, I know this is kind of a long video. I apologize. It's our last one. You're going to, for the Your Turn page, copy these two shapes into your notebook. And I want you to find the surface area and the volume for both. So surface area and the volume for the pyramid, and surface area and the volume for our cone. And we'll go over our answers and talk about any questions you still might have.